So in both the state diagram and the code trellis diagram, the current state and the input and the output and the next state, these are the four parameters that have been indicated. We should match them with the table given below where input, state and output are given. So first we will have a look at the state diagram and then we will see how a corresponding trellis diagram looks like. So in this given state diagram, the input state 1 is indicated by the dashed line and the solid lines denote the input state 0. Just adjacent to the lines, the numbers written are the outputs. Some of the outputs have been circled, like the one has been circled with a red circle, and there is 0 1 and 0 1 and 1 0 written just adjacent to the individual lines in the state diagram. These are nothing but the outputs. So what we need to look out for is the current state and the input and the corresponding output and what state the state switches to. So these four parameters need to be monitored. So we will now come back to the table and we will see when the state was A and the input was 1, what was the output. So if we look at the state diagram, when the state was A and the input was 1, it means we are talking about the dashed line. So from node A in the state diagram, where the dashed line is going to, we can see that the dashed line is going to the node B and its output, what is the output in that case? The output was 1 1 encircled using a red ink marker. So we have identified this output also and the first column of this table is complete. So we have the input, state and the output. At the second entry, we will write the state to which the state A has switched. State A has switched in response to input 1 to state B. And now we will write what will happen if to state B an input of 1 is given. So we will see in the state diagram that from node B where we are going when we have a solid line. When we have a dashed line because input state 1 is denoted by the dashed line. So from B we are going to D and we are going to have an output of 0 1. So this same has been denoted in this table and encircled using a magenta ink. So this is nothing but a convenient representation of state diagram in this table, and this representation has another form in the form of trellis. Trellis comes in very handy in implementing the exhaustive search algorithms and finding the minimum path using some search methods or algorithm that we are going to study for the purpose of decoding. So that's why we are going to study trellis, which is nothing but a convenient representation of the state diagram and this state and output table. So we will first have a look at the table and then we will see its corresponding representation in the trellis diagram now. So and again starting from the leftmost part, we are now at state A. So in the trellis diagram, we can identify the first topmost state on the left hand side as state A, which has a value 0 0. Suppose the input was 1. So we are talking about the dashed line. The input is 1. What is going to be the output? So the output is indicated on the trellis diagram as 1 1. And the next state is going to be B. So from B, if 1 is given to it, it means from B we are again going to have a dashed line. So we again come back to our trellis diagram and on the left hand side we will mark a node B and from there we will draw a dashed line. This dashed line will give you an output of 0 1. We will indicate that output 0 1 adjacent to the dashed line and it is going now to the next state which is D, which we can see from the table. We will mark the next state D on the next state panel, which is the rightmost column of this trellis diagram. So this trellis diagram has three columns. One is the current state column, another is the output column, and third is the next state column. So from state diagram, we can derive this table, and from this table, we can construct this code trellis diagram. So constructing this trellis diagram for one switching from the current state to next state is represented in this slide. However, there can be multiple switchings in different time steps, and for this, can be a cascading of individual trellis structures, and it grows bigger and bigger. Uh, it looks bigger and bigger in the domain of the page going from left to right. So whenever the time steps are more, we have to account for more switchings from the current state to the next state. Now the properties of convolutional codes need to be discussed. Each new block of k input bit causes a transition into new states. If I go back to this trellis diagram, each bit is causing the current state to move on to next state. So if we are considering that in a block of input there are k input bits, so it causes a transition into a new state. So there are 2 raised to power k branches leaving each state if we are going to draw this code tree. Assuming encoder has zero initial state, encoded word for any input of k bits can be obtained. Suppose the input sequence is 11101 and the encoded word v is equal to 1110010111111 and 11. How we are going to get this? We can get this by studying this state diagram.